Okay, so now we got to sober up. The point I was trying to make was, did we talk about distributorless ignition?
No, you started to, I think,
Really?
or you were going to.
Huh. Okay.
I think.
Well, if I didn't have to make the same drawing twice, it'd be a lot easier. Quack. Um. All right. Golly. Yep, there is electronic ignition. There is. Okay, so distributorless ignition. Okay, the third ignition system we need to study is called distributorless ignition. And as you can imagine, based on the name, that means that there's no more distributor. Now, why? Because a distributor is a mechanical part. For instance, this is the distributor off of General Motors 74 through probably 90. It's called the HEI distributor. It's really, really big here because the voltages were so high we had to keep them from touching each other. Remember, the higher the voltage, the further apart we have to put everything. And that's because high voltages tend to jump. So you will see, for instance, in the National Electrical Code or in the distributor cap, you'll see that the higher the voltages are, the further apart we have to place everything. In fact, that's why when you look at like the transmission lines that have like 750,000 volts, they're way higher than the ones that are 500,000 volts because after all, we have to keep the wires further apart. Also, if you look at the insulators, the thing that holds them onto the towers themselves, those wires, the insulators themselves are like 15 feet long. They're crazy. You would never think they were that long unless you just sat there and actually looked at them. And it's like, wow, why do you need a 15-foot long insulator? Well, because it rains, right? And when it rains, everything gets more conductive, and those towers are going to be grounded. So when you've got 750,000 volts to ground, you probably want 15 feet worth of insulator. So this right here is an old distributor out of the old GMs. And I wanted to use it to show you what we've been talking about. This right here is a vacuum advance. It's what we used to do to set the timing mechanically. And this right here is a centrifugal advance where the weights go out, they spin out as the shaft moves faster. Distributor shaft, remember, is geared to the camshaft. And that's going to advance the timing. What we're going to talk about tonight is timing and spark advance. But what I wanted to show you was down in there on that shaft. Can you see those spiky things? The spiky things are the trigger wheel. And if I were to there we go. If I were to turn this shaft, you would see that the spiky things are going to turn as well. And those spiky things are the trigger wheel. And you'll notice that there's 8 spikes corresponding to a V8 motor, which is what this distributor would be installed in. The pickup coil is underneath that, and this big black thing right here is the ignition module. So that's what we were talking about last time. I just wanted to show you how it looked like back in the day. And we've got a vacuum advance mechanism and a centrifugal advance mechanism, both of which were mechanical, so they both did terrible jobs. But it was good enough when that's the best we had. So let's go to distributorless. Distributorless is going to look like this. Top view. Instead of having 1 coil, because that was a problem, now we're going to have 3 coils. And this one is going to be, what, 2 and 5. And that's going to be 1 and 6. And I believe this one's 3 and 4. Each coil is going to serve only 2 spark plugs. This is called the waste spark system. And the primary thing that we need to understand about this is that distributorless means that we no longer have a distributor. Okay, so how then do we know when to fire the spark plugs? Well, because by now we have crankshaft position sensor, camshaft position sensor, so we know exactly where everything is. We don't need a distributor anymore, so why keep it, is the theory, which is a good theory too. Because what's happened now is instead of having all these mechanical systems to run our ignition, now we're going to do it all with computers. And that means we're going to have the perfect spark advance for every combination of engine speed and engine load. And that just made performance phenomenal, because this mechanical stuff was just like a carburetor. It was always an approximation. And we always had to tune around the worst possible possibility in terms of, detonation and bad things happening with the engine. So as a result, it was always an approximation, and it never got the performance that we can get now out of much smaller engines. Okay, so here's how the waste system works. We didn't have the sophistication. We didn't have the sophistication yet to run a coil for each cylinder. But we figured out a way to run two spark plugs, fire two spark plugs at the same time. Now, we can control two spark plugs, and that's going to be 3 times better than just one coil, because the big problem that made this so important is as engine speed increases, spark gets weaker. Now, is that a big problem? Yeah, it was a big problem, because when we had one coil, back like our drawing here, when we had one coil that was serving 4 cylinders, we didn't have much time for that. Well, let's just look at the diagram so I can review. Oh, come on. Golly. Oh, I didn't earn my money. That's good. There we go. When we had one coil and it was serving 4 cylinders, problem was, remember what's going on in the ignition system. When we close the switch, the coil trigger closes the switch going to the coil, then we're going to get current flow through the primary. Current flow through the primary is going to create a magnetic field. That magnetic field is going to induce a voltage in the secondary. Then when we open up that primary circuit, there we go, right there. 12 volts going to the coil trigger. Trigger starts the process. When we close the coil trigger, there's going to be current flow going through the primary. That's going to build up a magnetic field. When we open up the trigger, this magnetic field is going to collapse because it's not going to have current. Well, the important thing is when we're building up a magnetic field here, it's going to induce a voltage on the secondary. So when we open up this switch, now there's all this energy here. And what it's going to do is it's going to look for the lowest resistance path to ground, which better be down the center electrode to the side electrode, creating an arc, which is going to ignite the air-fuel mixture. Well, the problem is the more spark plugs you serve with this, the less time you're going to have to build up a strong magnetic field. Well, if you don't build up a strong magnetic field, you're not going to get all kinds of voltage coming down this wire. And that became an issue that we will now look at. There we go. So turn your paper this way. We will make a chart that says, well, there's 3 things we're going to be doing down here. So it's going to say 1 cylinder, 1 coil, 1 cylinder, 4 cylinders, 1 coil, 8 cylinders, 1 coil. back here. There we go. All right, and we're going to have, well, basically 4 engine speeds, but really 3. We're going to have idle, which is 600 RPM. We're going to have cruise, well, what used to be cruise before we got overdrive transmissions, of 3,000 RPM. And we're going to have power, like we're accelerating up an on-ramp, and that's going to be 6,000 RPM. Now, just over here in the corner, I'm going to put S2000 because the red line is 9,000 RPM. So let's see. Well, we know that the spark plug fires every other revolution. So if the engine is going 600 RPM, then each spark plug must fire 300 times per minute every other revolution. Well, 300 times per minute is divided by 60, 5 times a second. Oh, did I mention that math was racist? And that would be 200 milliseconds to build up and collapse a magnetic field. Now remember, half of that time is building up, half of that time is collapsing. So it's really less than you think. But 100 milliseconds is 1/10 of a second. That's actually pretty good in electrical terms, but it's only going to get worse, as you can imagine, as we increase engine speed. So let's see what happens. If we're going 3,000 RPM engine speed, that means that 1,500 times a minute, that spark plug is firing. So that coil has to build up and collapse a magnetic field. That is 25 times a second. And that means that we only now have 40 milliseconds to build up and collapse that magnetic field. As you can see, we got a lot less time. Now you say, well, doesn't electricity move the speed of light? Yeah, but since the coil is an inductor, it's got counter EMF, which is to say it creates resistance to the flow of current into it. So it's not really as quick as you think it is. It builds up, because what happens is when you build up the magnetic field, then it starts to oppose the flow of current into it. That's called counter EMF. Sucks. That's an inductor for you. All right, so at 6,000 RPM, that means each spark plug is firing 3,000 times a minute. Yeah, now see, here's the thing about math. Math is the only thing that's going to enable you to understand what's going on inside this engine, because this is happening way too fast. If I just looked at the spark plug, it would look like a blur because your eye can't really see any faster than that. So let's see, that means that each spark plug is firing 50 times a second, which means that we only have 20 milliseconds to build up and collapse that magnetic field, small m, big S. All right, so let's say that we got the same coil, but now it's going to be supplying 4 cylinders. See what happens. All right, so that means that 1,200 times per minute, that coil is going to fire because it's 300 times 4 cylinders. That means that the coil has to build up and collapse the magnetic field 20 times a second, which means we have 50 milliseconds. Later on, we're going to say, boy, I wish we had that much time, because we got to build up, collapse the magnetic field through the flow of current. It's going to take time. Okay, but things are about to get a lot worse. Now, at 3,000 RPM, we're going to have to fire the spark plug 6,000 times per minute, which is 100 times per second. Way faster than the eye can see, which gives us only 10 milliseconds. Uh-oh, because remember, that's only 5 milliseconds to build and 5 milliseconds to collapse. Now, I mean, a millisecond, you can't fathom that much time. The only thing that's going to pick that up is a very powerful oscilloscope, really. But let's say we're going 6,000 RPM. Now, that means the coil has to fire 12,000 times per minute, 200 times per second. You would never believe this if I didn't show you the math. That means you only have 5 milliseconds to build up and collapse a magnetic field in the coil. of which only 2.5 is for buildup. So as a result, you can't really build up that strong of a magnetic field. As a result, you ain't going to induce a whole bunch of voltage on the secondary. Now, let's say that you had a Honda S2000 with a 9,000 RPM red line. That means if you had it with a single coil, that coil would have to fire 18,000 times per minute, which is 300 times per second. See, this is what's infuriating to me, because without math, you would never in a million years understand this. But since math, we know it can't be any other way. That means you would only have 3.3 milliseconds to build up and collapse a magnetic field. That's next to nothing. As a result, you're not going to get a very strong spark. Can you see that as the engine speed increases, you're going to have a weaker and weaker spark? But that's not the worst part. The worst part is, back in the 60s, the most powerful engines we had, 426 Hemi, had one coil and 8 spark plugs. So with an 8-cylinder, that's going to fire the coil 2,400 times per minute.
One coil with 16 spark plugs.
Well, that would be 2
The
coils.
Hemi and two spark plugs.
That's the race Hemi, right? Yeah.
No, even your standard Hemi ran 2 spark plugs. Look in the CUDA. In the history of the CUDA, when they put the Hemi in, it had 2 spark plugs per cylinder.
Chuck, you're our tiebreaker. What do you think? Uh-oh. Chuck has left us. Chuck has left the building. All right.
I'm not sure. I always believed they only had one spark plug in the first generation of Hemis and 2 spark plugs on the second generation.
Yeah, I'll believe that, because they had 2 distributors, probably because of this issue, so they could run 2 separate ignition systems, really. Yep. So 12,000 times per minute is 200 times per second. That's 5 milliseconds. Now, at 6,000 RPM, if you're firing 8 plugs with 1 coil, that means the coil has to fire 24,000 times a minute, which is 400 times per second, which you would never believe if I didn't prove it to you with math. And that only gives you 2.5 milliseconds to build and collapse that magnetic field, of which only half of that is building. So as a result, you're not getting any energy transmitted to the secondary, and that comes off as a weak spark. Okay, well, if the spark is weak enough, you're not going to get combustion. And if you don't get combustion, you're not going to get acceleration, right? Your engine is going to refuse to go any faster. Now, can I go ahead and point out that if you have 1 coil per cylinder, you're going to have 8 times as much time to build the magnetic field. Look, 2.5 versus 20, that's a factor of 8. As a result, you're going to have 8 times stronger spark if you have 1 coil for each cylinder, and that's what we end up doing in coil on plug, which is what we use now in pretty much every application. That's why. But if I didn't show you the math, you wouldn't believe it. Now, here's the thing about that. Look, 1 cylinder, 1 coil. Did you realize, I mean, because this is how often the spark plug is firing, so it's firing 50 times a second at 6,000 RPM. The intake valve is also opening and closing 50 times a second. Exhaust valve is also opening and closing 50 times a second. S2000 has got a 3-inch stroke. It's going from a dead stop at bottom dead center to over 100 miles an hour to a dead stop 3 inches later, and then over 100 miles an hour to a dead stop. It's doing that 50 times a second. Now, since it's math, it can't be any other way. Decide. I don't know what it just seems like really demonic to me to say that math. There's no certainty in math. What else is there certainty in? I mean, okay, so 2 plus 2 isn't 4. If I wanted to destroy people, you know what I'd do is I'd say, how many fingers am I holding up? Wasn't that was in Big Brother. It was also in one of the Star Treks, right? It's like, how many fingers am I holding up? And I'm going to keep torturing you until you say 5. Say 5 and I'll quit. And I was like, okay, that's 5. All right. You have been assimilated by the Borg. Congratulations. And here's your Twinkie. Here's your Instagram account. So this is an important chart. And when you start thinking about all the stuff that has to happen mechanically, you'll see that, you know, in a trip to Las Vegas, your valves probably open and close a billion times. Just Las Vegas and back. Change your oil, folks. That's what I can tell you. Okay, so the waste spark system, we did not have, you guys got that?
Yeah.
Waste spark system. Anna Maria, did you know we're going back to school on the 15th or whatever it is? Yep.
Sorry, I was on mute. So when?
I believe it's on the 15th, April 15th.
Oh,
Yeah.
April 15th. Oh, I was hoping it would be the 1st of April, but okay.
Yeah, no, it's because my stupid union required 2 weeks of prep time. So it's going to be April 15th. Yeah.
Had all
Tax
year
day.
to prep. Okay, fine.
Tax day. Yep. Or
Okay,
cupcake days, I call it. That was a joke.
all right.
Yeah, we're all going to stay 6 feet apart. Don't forget. Yeah. The point I was trying to make was, as engine speed increases, the spark gets weaker. So what we needed to do was, we have multiple coils now. Now what the waste spark system did was, it created a circuit where, let me show you. Right there, no, there, no. Well, that's what the whole system looks like, but I wanted this one right there. There we go. Okay, well, what do we know about circuits? Well, we know that this is a complete circuit if you go through the cylinder head. And what we see is that the secondary is hooked up to 2 spark plugs at the same time. So this creates a complete circuit, so we will have current flow. This is the primary. This is the secondary. It's just another transformer. But now it's going to fire 2 spark plugs at the same time. Okay, well, that's why they call it a waste spark system, because these are companion cylinders. And what that means is the piston is at the same location all the time, but it's 180 degrees out in terms of the 4-stroke cycle. So when one piston is coming up on the compression stroke, the other piston is coming up on the exhaust stroke. And they go like this. They're just 2 strokes out on the 4-stroke cycle. So usually when we would fire a spark plug is while the piston is coming up on the compression stroke, and we still do. But at the same time, we're going to fire the spark plug on the other cylinder when it's coming up on the exhaust stroke. The question is that going to hurt anything? No, because what's in the exhaust stroke? A bunch of smoke. Now there is some unburned fuel and there is some oxygen. So maybe, just maybe, we might reduce emissions a little bit. But that's the reason they call it the waste spark system, because what we're doing is we're firing 2 plugs at the same time. Funny thing is, this plug, the arc is going to go from the center electrode to the side electrode. On this one, it's going to go from the side electrode to the center electrode. It's going to be reverse polarity. And then it swaps over. Okay. Why? Because that only required us to have half of the computer sophistication that we needed to do what we know we were going to get to eventually, which is coil on plug, 1 coil per cylinder. All right. So what we see is electronic ignition and distributorless ignition were transitional phases between where we came from and where we knew we wanted to end up. Just like throttle body injection was a transition between carburation and port fuel injection where we knew we wanted to end up. You know, throttle body injection just means that we had 1 or maybe 2 injectors right on top of the throttle body. So it's not spraying for any individual cylinder, it's just kind of spraying. It does have an oxygen sensor, but we weren't that good at running oxygen sensors or PCMs or anything like that yet. So throttle body injection was a transition between carburation, which was a purely mechanical system, and the port fuel injection that we wanted, where we can control fuel flow into each individual cylinder. And it bought us some time, basically. Well, likewise, electronic ignition and distributorless ignition bought us some time so that we could wait to get to coil on plug, 1 coil per cylinder, where we are today, which requires us to control each individual coil independently, which takes some pretty hardcore computing power. So that's why we had this transitional system. Now, I'm not going to spend too much time on this system other than to say, if we had a broken spark plug wire here, the symptom would be you'd lose 2 plugs instead of 1. That was kind of cool. That was kind of interesting. But this puts out a hell of a spark, I'll tell you that. This puts out a hell of a spark, and if you ever touch it, you get nailed. You'll notice. But this will put out probably an inch-long spark, white, blue, really hot, really, really nice. So that's why they call it a waste spark system, because it's going to fire the spark plugs 2 at a time, twice in every 4-stroke cycle, and it's going to fire a spark plug in the middle, well, not in the middle, but towards the end of the exhaust stroke where it doesn't really matter. All right, so that's the diagram for a V6. You can see that they're 12 volts anytime the ignition is on, and then the coil trigger is actually triggered by the PCM based on crankshaft position sensor, camshaft position sensor, coolant temperature sensor, intake air temperature sensor, a whole bunch of stuff. Because now we're getting into some sophistication when it comes to electronic engine control. Now, I told you in the distributors, and I showed you just a few moments ago, that the distributors only had mechanical systems to control how the ignition system operated. That was a problem. But before I explain that, let me explain what we have to do.
Everybody make sure you get on the roll sheet.
Combustion takes time. Now, we usually think of combustion as being an explosion, but it's not. Gasoline has a speed limit in terms of the flame front. I think it's like 25,000 feet per second. It takes time. Now, in the theoretical 4-stroke cycle, once the piston gets to top dead center, then all of a sudden you fire the spark plug, but that's not how it really works. Look, if I'm having a barbecue and I want to start cooking at 5, I have to light the coals before that, right? So that they'll be ready when I want them. Or, for instance, if I'm playing softball and I'm up to bat and somebody's pitching, I have to start swinging before the ball gets to the plate, so that by the time the ball gets to the plate, my bat will be there. That's a better example. Now, my question is, let's say somebody's pitching at 50 miles an hour. Okay, so in order to make sure that my bat is over the plate when the ball gets there, I have to start swinging the bat before the ball gets there. Now, what about if the same person's pitching at 100 miles an hour? I'm going to have to start even earlier. And this, my friends,
You have to keep swinging faster and faster.
Sooner, because we can't do it faster because combustion takes time. All right, this is something I thought up for my good friend Chuck. So the 5 elements, did I do this already? The 5 elements of tune-up? Well, we used to call it tune-up, now we don't. It's called engine performance. Did I do this already?
No.
Okay, thank you. That would be air, fuel, spark. Oh, shoot, sorry. Doggone it. Get excited. Advanced. There we go. Air, fuel, spark, timing, and compression. That's the combination that's going to make your engine run good. I've never seen this before. I made this up, so it's all part of your $80. since August. It was a joke. Anyways, air comes from the downstroke of the piston during the intake stroke.
Fire.
Fuel comes from the fuel system. Spark comes from the ignition system. Timing refers to where's the piston in the cylinder when the spark plug fires. And compression means how much are you squeezing the air fuel mixture before you light it off. That's going to determine how much power you're going to get out of the resulting combustion process. Okay. Timing refers to the relationship between spark plug firing and piston location. Where in the cylinder is the piston when the spark plug fires? Because like I said, in the theoretical 4-stroke cycle, the piston goes all the way to the top and then we fire the spark plug. But we can't do that because the piston's constantly moving, reciprocating. So we actually have to start the fire while the piston's still coming up so that we end up with maximum pressure when the volume of the combustion chamber is at the minimum, and that's going to give us the most force. In physics, we would say F equals P over A. That means force equals pressure over area. Okay. So in order to make this number, because this force is what pushes the piston down, in order to make this number bigger, we have to make either the pressure higher or the area smaller. See, the bigger this number is, the bigger this number is going to be. The smaller this number is, the bigger this number is going to be. That's why you think of a diesel motor, it's got twice as much pressure as a gasoline motor. That's why you can see things like 1,000 foot-pounds of torque on the new Ram Cummins. Now, this area is the thing we need to concern ourselves with now, because we've got a cylinder like this, and it's got a combustion chamber like that. Well, here's another one right here. Same thing. But now what we're going to do is, before this piston gets to the top, let's say, oh, I don't know, that far before the piston gets to the top, that's 14 degrees. 14 degrees of what? 14 degrees of crankshaft rotation. Remember, as the crankshaft rotates, yes, I did go to school on Wednesday. That right there, that's a piston and rod assembly right there. Okay, so as the crankshaft rotates, the piston goes up and down, yeah? So let's say that a circle is 360 degrees. So 14 degrees before the circle is completed and the crankshaft makes a complete rotation, so the piston's not all the way up to the top yet. 14 degrees before that, we're going to fire the spark plug. We would say 14 degrees before top dead center, which is what we call it when the piston's at the top of its travel. So that's 14 degrees before top dead center.
TDC.
TDC, buddy. Yeah, Citrus has got to come up with a recruiting video pretty quick. But tell you what, this is on a slow engine speed. Say it's going 1,000 RPM. We are going to fire the spark plug before the piston gets to the top so that by the time the volume is the smallest, the pressure will be at the maximum, right? So we're going to kick this number as high as we can get it when this number is as low as we can get it. Now you say, well, this says area, but not volume. That's because volume is just a three-dimensional area, I think. Okay, but see, this engine is turning fast. So we need to, again, start the process sooner. In order to get maximum pressure when the volume is at minimum, we're going to have to start the process sooner. So the piston is going to be further down in its travel. Remember, they're both going up, though. Can I ask you a question? How is it that Dr. Seuss gets canceled for some book he wrote 15 years ago, but Cardi B gets played on the radio 18 times a day for, you remember what her single was? Yeah.
WAP. The WAP.
Yeah, right? Okay, so, but did they stop selling that album? No, but they stopped selling the Dr. Seuss books.
No, they're not going to stop that album.
Yeah, yeah,
Green eggs and ham, my favorite.
right? So let's say this is 28 degrees, crankshaft degrees. We would say that's 28 degrees BTDC for a engine that's spinning, I don't know, 3,000 RPM. Let's say that's 1,000 RPM. See, in order to get maximum combustion pressure, because combustion takes time, in order to get maximum combustion pressure when the volume is at the lowest, we have to start earlier. Just like if someone's pitching faster, we have to start swinging earlier to get our bat and the ball to meet over the plate.
Good
That
analogy.
right there is called spark advance. Because the timing.
Move it up just a little bit.
Oh,
Move your
sorry about that. Sorry about that. Because we have to keep firing the spark plug sooner and sooner in order to get maximum pressure with minimum volume, which is going to give us the most downward force on that piston, which is more power, greater efficiency, whatever you want to call it. Ooh, let's skip way too far ahead on that. All right. Yep, spark advance refers to firing the spark plug sooner based on different engine conditions like RPM and load. Yeah. Because this is true for RPM and it's also true for load and it's also true for rich mixture, lean mixture, warm engine, cold engine. But we'll talk about that in a moment. Okay. Let's see how we do it when we don't have to deal with distributors. And how we do it, did you get that? Okay. How we do it is by doing what's called ignition mapping. Oh, I wanted to get a freaking dyno. I came to the realization, you know what? I can get a freaking dyno. I just wish I had a place to put all this stuff. Ignition mapping right there, which means what we're going to do is now instead of having these mechanical assemblies that were like carburetors and they were just like approximations, all
that
the
would
time,
be fun.
now what we're going to do is we are going to go into the programming of the PCM and we're going to put this engine on a dyno and we're going to have every possible combination of load and engine speed. And we're going to find exactly the best spark advance for that combination. And we're going to program it into the computer so we get it all the time. That's called ignition mapping. And it's really made all the difference in terms of really getting insane amounts of performance out of very mild engines, but we're just running them right now. So let's see what ignition mapping looks like. We come over here. Nope, to this one. Nope, to that one. There you go. Well, let me make it easier first. What we're doing is, this is all the different engine loads from high to low. I'm to low to high, I'm sorry. And this is all the different engine RPMs. And what we can see is, this has got to have, I don't know, 15 degrees in this block. And it's got to have 30 degrees over here and 45 degrees over here. So basically what we're doing, at least as far as what GM did, was they went from minimum engine speed to maximum engine speed, and they broke it into 100 pieces. They went from minimum load to maximum load and broke it into 100 pieces. That gives us 10,000 data points. And they put the engine on a dynamometer, and they found out exactly the best advance for that particular combination, and they programmed it into the computer. So now we have the perfect spark advance for every combination, which is why engines run freaking awesome now. This is what the chart looks like. If you were smart, you could go take high performance auto at Citrus College with Professor Brown, and you would be doing this yourself. This is what tuners do when they set up your ignition. I don't believe tuners are the people that call themselves tuners. No, they ain't doing this. No, they ain't doing it. They're probably setting the fuel, but I don't think they're setting the spark. No. And you end up with this thing, this pretty little thing that's called a map. And what they're doing is they're applying these values to a three-dimensional map, which is to say, you've got all the combinations of engine load from low to high here, all the different combinations of engine speed from low to high here, and then up here is how much spark advance you have. And
Tuners do it through fuel and spark advance.
no, they're supposed to. I don't believe they do, because the ones I
true
talked
tuner, a true tuner.
right, the ones I've
Not-
talked to,
Not
all
the
they're
dude
doing is
just
fuel.
sitting on in the corner little performance shop.
Right.
An actual tuner will actually run both.
But if he didn't have if he doesn't have a dyno, he ain't doing it.
Yeah, I know. Like Sheepy Racing,
It's Larry.
they do it on dyno and tune on dyno.
Right. There's another one right there. Now, this is for a turbo vehicle, because you can see that the vacuum goes negative and it goes positive. So one's vacuum and one's boost. And over here is RPM. And this is different spark advances for different situations. As you can see, it's not linear. It's not a smooth map, which tells us that there's no possible way that a mechanical spark advance of any sort could ever make a map look anything close to this. Well, if it doesn't look like this, then it must not be right. It's an approximation, just like carburation. Oh, incidentally, Chuck, Via Verde Plaza, Friday night, 3 to 8. You know where Via Verde is? Across the street from Raging Waters? 3 to 8, Friday, classic car cruise night.
Ooh,
And it's free. Yeah, that's the best part. Okay, so here's what you do in Professor Brown's class over at Citrus, the high performance automotive. You got to get this dot in that target. So what do? Is you vary engine speeds and throttle pressure, and it populates this chart. And that's how a real tuner goes for every combination of engine speed, and this is another turbo car because it's got negative and positive values, for every combination of engine speed and engine load. That's the right way to do it. That's why they charge so much, which is why these freaking jackasses down here, I know what they do. They go to a deserted street with an air fuel ratio sensor in the exhaust pipe, and they do a couple of burnouts and they fit up the fuel, and that's about it, which is why they'll blow freaking holes in their piston all day long and say it wasn't their fault.
Or they download from a actual
Right.
tuner a tune.
Right. But you know, what if your car's different? What if your car has a different, if your car has a different tire diameter, it's going to be different. So that's an approximation.
Exactly.
This is what it looks like. Yeah, so these people are charging top dollar, but they sure as hell ain't doing top dollar work. I mean, it's a lot of work. I mean, it took us a while to fill out, one row. Me and this other dude, and we were just sitting there like, they built some kind of weird Toyota Supra over there. No, not a Supra. I forget what it was, but Turbo Yaris or something. I don't know what it was, but whatever it was, we were just like programming the computer with it on what, a EFI Live or something like that. And that's what this looks like. And that's ignition mapping. So it gives us the perfect amount of spark advance for every application. That's freaking groovy. And, you know, that's why folks, you know, people talk about the good old days and blah, 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 but I was there and they were not that good. So that's ignition mapping. Dynamometer tested optimum advance for every combination of engine speed and load. Now let's talk about this, because this is potentially an engine killer. Spark too soon. All right, spark too soon is called over advanced. That means you got too much spark advance. The spark's happening too early. Now, can you see that when the piston's coming up on the compression stroke, if you fire the spark plug too early, it's going to make the piston want to go back down? That's called detonation, knock, or a ping. And what it's going to do is it's going to beat the hell out of your bearings. It will literally beat the bearings out of your engine. And it'll make your piston rock in the cylinder. It's insanely destructive, insanely destructive. So as a result, we have to watch out for that. Causes detonation, knock, or ping. These are all the same thing. Very destructive, very destructive. And you say, okay, well, why don't we just run it way less advanced then? Because that's a separate problem. That's called retarded, right? There's advanced and there's a retarded. Watch, 10 years from now, we're going to have to, we won't be able to, anyway, we won't be able to teach ignition systems. That means spark too late.
That's a discriminatory word.
That's it. That's ableist. Yeah, I went to college. Too long. Spark too late. Now, what does spark too late mean? Spark too late means we're getting the combustion pressure, but by then the piston's already well down in the cylinder. As a result, the volume is way bigger. And we can see from this formula here somewhere. Yeah, we can see from this formula that if the area is greater, then the force is going to be less. So let me ask you a question then. What is the #1 symptom of retarded timing?
Low power.
Low power. Good. Yep. Yep. And you're going to get bad emissions, bad fuel economy, all that. Yeah. So where do we want our spark to be? Just right. Not too quick, not too slow, not too late. Yep. Now we have maximum safe advance at all times, because what are we going to install on our car so that we don't get too much spark advance? Knock sensors. CAS, all right? That's what it looks like. All right, what does the knock sensor do? The knock sensor is a sensor that creates voltage out of vibration. And when it starts to hear the knock, what it's going to do is it's going to report that to the PCM, and the PCM is going to back off the timing by 2 degrees to see if it can fix that problem. That's cool. That means we guaranteed we're going to get the exact right spark advance for elevation, for air temperature, for coolant temperature, for uphill, downhill, any type of gasoline from anywhere. We're always going to optimize our utilization of the gasoline. I mean, this is just tremendous technology, and it's not space age stuff. It's just the logical extension of what we've been, working on for the last 40 years. The knock sensor doesn't do anything other than report to the PCM, which is going to retard the timing by 2 degrees because your timing's over advanced. Now, will your knock sensor only sensor on knocks? No, sometimes if you lose like the guide to your timing chain, or if you got too much piston slap or a million other things, it'll still go off. or if you have a, broken bracket or a bad pulley. Yeah, it's been known to do it. LS Motors got 2 knock sensors because it's twice as badass. It was a joke, but not really. So that's cool. Now, knock is the uncontrolled and violent combustion. Yeah, that's no good. Now, is that the only thing that can cause it? Well, there's this thing called pre-ignition, which means, well, let's see. Pre-ignition. Hey, Rudy, what's pre-ignition? I keep forgetting.
It's where the ignition fires sooner than what's expected because the computer is sensing it to.
No, my love. It's combustion before the spark plug fires. Very,
Sorry.
very destructive. Yeah, very, very destructive. Yeah, it's been a long time. Okay, what would cause combustion before the spark plug fires? Lean mixtures,
Your air is too hot going in the motor.
hot engine, hot air, lean mixtures, deposits on top of their pistons or valves, heavy loads. Yeah, because basically it's like dieseling, right? Basically, when the engine gets hot enough, we used to have a big problem with this back in the early 80s because the engines were running so hot and running such lean mixtures.
Yeah, you could turn your car off and then keep running for.
Yeah, dieseling. Yep. Okay. That's about that, what I wanted to talk about on that. Oh, what's this? Octane. Octane is resistance to burning. And it's something that we put in fuel to keep detonation, pre-ignition, stuff like that from happening. Basically, what we did was we put octane in the fuel so that we can run higher compression ratios and we can run more spark advance, both of which will give us more power, more efficient engine operation, whatever. Well, back in the olden days, we used to put lead in the gasoline to increase the octane rating because it would stop the gasoline from being so volatile. Problem was, lead's really poisonous and it was making everybody stupid and violent. True story. And also it was killing catalytic converters. So what we had to do was we went to unleaded fuel. This is what, 74, 75, something like that. Well, unfortunately, the substitutes for lead were way more expensive and, well, or at least that was the excuse they told us. So let's look at octane ratings. Octane is resistance to burning. That's why on a higher performance, higher compression engine with more spark advance, you're going to need to have more octane. Quack. All right, let's look at different fuels. Regular, mid-grade, premium, and racing fuel.
Lowest octane I've seen is 83.
Ooh, really?
Mm-hmm.
Highland Park?
Back east.
Regular is going to have an octane of 87. Mid-grade probably have an octane of 89. Premium probably have octane of 91. And racing fuel would be like 102.
100 and up.
Yeah. Mm-hmm. Now, you say octane is
All the way
resistant
up
to
to
burning.
110.
You say octane is resistance to burning. Why would I want to put that in my engine? Don't I want to burn? Well, yeah, but here's the thing. If you don't have a high enough octane rating, you're going to have to cut down on your compression. If you don't have a high enough octane rating, you're going to have to cut down on your spark advance. And you're going to lose more power than you gain by having a low octane fuel. I think that's the big thing about E85, is that it does allow you to run more spark advance, more compression. I suspect. Of course, it's going to chew up the inside of your engine, but But who cares? We can always afford another one. So now the question is, what happens? My car has 11.3 to 1 compression, which is why you probably shouldn't put a supercharger on it. I just suspect. Now it's got 11.3 to 1 compression, which is probably the highest compression ratio of any modern vehicle. And it requires premium all the time. Now, what happens if I don't put premium in it? Well, what would happen is if I put in 87 with that higher compression and with as much spark advance as that engine has, it's going to start to knock. Then the knock sensors are going to pick up on that, and they're going to tell the PCM, hey, retard the timing. Well, they're not. They're going to report to the PCM, and the PCM is going to retard the timing. And what if that doesn't get rid of the knock? Then the PCM is going to retard the timing some more. And pretty soon we're going to be retarding the timing so much that we're going to lose power. Get it? So can I run regular in that car? Yeah, but I would lose a ton of power doing it. So I don't, because a hero must never let down his fans.
And you cannot run regular in the Cobra at all. It's what causes knock in that car. The computer cannot retard the timing enough
Yeah.
for it to run regular.
I don't even remember there being a knock sensor on that, is there?
There is. There's 3 of them.
Huh. And that's got a hemispherical combustion chamber.
One up on top.
That's got a hemispherical combustion chamber. It should have less of a problem, not more. All right. So
No,
anyways,
that car has 3 knock sensors in it.
okay.
And that's why it requires only premium fuel.
So,
Well, probably because all the tire smoke coming out of my car, 300 yards ahead of it.
so what's the difference if you have a car that requires regular and you put premium?
You will get worse gas mileage.
Worse gas
Negative.
man.
Yes, you would. Now, okay,
Negative.
here's the thing. There's 2 things about premium. It's got higher octane, which is true, but it's also got a lot more detergent. Now, that detergent is what cleans the inside of your fuel system. It's also what cleans the inside of your engine. So the suggestion is once a month, you should fill up with a tank of premium. Because
Usually when you start a trip,
Well, okay.
when you go
Okay, well,
take it
that-
on a road trip, you want to run your first tank with premium so it cleans out the motor. That's
So,
what I
okay, so
do.
I get that.
all the
Okay,
time.
so you're doing a big road trip, which I do a lot of. Okay, so once a month or before the road trip or once a month would be recommended or good?
don't
The
overthink it.
First
Okay,
tank of your
well.
trip. So
Don't overthink it.
say you're going to take off on Friday. When you need gas on Thursday, fill it with premium.
It doesn't matter to me. But I don't obsess on these things, right? Because
Okay, so that's simple, but like I wouldn't want to regularly use premium when my car would just require regular.
absolutely
because
correct,
I would
yeah.
lose,
yeah,
I would
absolutely
lose,
correct.
what'd you say, gas
Gas
mileage
mileage and power. Yeah. Yeah. Because
and power?
it won't keep advancing the timing.
Okay,
Use whatever gas your engine is supposed to burn. And premium has higher detergent, so it's going to clean stuff out. So that's cool. I mean, it might clean some of the mung out of your injectors and such. So that'd be useful, but I wouldn't run it all the time if it was supposed to run on regular. Run it.
okay, just asking.
Mr.
Probably more important, I must say, probably more important than running premium versus regular is where the hell you're getting your gas. Because
Oh, okay.
if you're getting your gas at some of these places I can't mention, but probably someone else could,
Like
Okay.
the wholesale houses?
right?
What?
So if you go to Shell, 76, Chevron, major top tier places like that, you'll be fine. You just got to watch out for these weirdo places that get their gas from who knows who.
USA.
Mr. Oakcliffe, I have a question. So I was told that like the gas that comes from the wholesale house, the like, what I'm talking about, the wholesale house, that has the gas
Big-
stations,
Big
costs a lot
market.
for Sam's.
Really?
Mhm.
What about it?
So I heard that their gas is just as good as Chevron 76
Yeah.
and everybody else
All
is.
top tier.
And it was saying,
Most of the time they buy from them.
and somebody was telling me that that if you just use that Lucas fuel treatment stuff, is that just garbage or what?
No, it's probably okay every once in a while, but you know, it's not like a requirement.
Just don't let it sit in your tank for long periods.
Yeah.
What are you talking about? Like,
If you're going to use one of the fuel system cleaners or fuel treatment,
yeah,
don't let it sit in the tank. So remember, like we were talking about putting premium in your first tank. If you
yes.
throw fuel system cleaner in there and you're going to run that full tank all the way out and fill up again, then put your fuel system cleaner. Don't put it in there and let the car sit around in your driveway as you go just doing your daily errands. Because that fuel system cleaner will chew up your fuel tank.
Why? It's got a lot of alcohol on it.
Okay, so like for instance, I don't drive that often. I'm pretty local. I don't drive big miles unless I take a trip. So I wouldn't want to do that regularly. Is that what you're saying?
No, don't do it regularly. No.
Okay.
No, I never do it. So that tells you how I feel about it.
All right.
I only do it when I'm taking the car on a long trip and it's been city driven for a lot. If you
All
drive
right.
your car just around the city and you're taking it on a long trip, that's when you want to put a fuel system cleaner and premium to burn out the tank.
We can't spend 5 minutes on this topic though, folks, because we got too much stuff we got to cover.
Okay. All right. Sorry. Okay.
Right, so no, it's cool. I mean, now that we got an end date to the lectures, we got a boogie.
No, that's true.
So it says set with a timing light by turning the distributor. If you look at this distributor, initial timing, that's back when you used that. Now, is Roko's going to show you how to use a timing light? Maybe if you show up with a car with a distributor, but since you probably won't. See, this has a slot in it. This is a distributor. This has a slot in it, and we used to turn this distributor to set the initial timing, which is to say, how much spark advance do we get at idle speed? That had to be set with a timing light. But since you're probably never going to see a car with a distributor anyway, I'm not going to spend too much time on it. I guarantee you, though, that you can find out all this information on utubo, el tubo da u, de u. So this is old. This is old, 20 years old. So I don't feel like teaching it is appropriate anymore. All right, so right there, spark plug wire, next topic. Yeah, sorry about that, folks, but we are looking towards the shutdown of the space station, as it were. Spark plug wire is the number one least reliable part of the engine. It's delicate, it's vulnerable, reliable part of every engine that's got one. So let me show you what it looks like here. Looks like that. You say, man, that conductor looks really small. Yeah, it is. Because what's important about a spark plug wire is not the conductor, it's the insulation. All of this right here is insulation, right? So I'm going to come in here with an arrow and say plastic insulation. This part over here is the silicone jacket. And this part right there is the conductor, which is carbon impregnated fiber, basically string. It's not wire. That right there is a spark plug wire. It's not wire. This, as you can see, it's just freaking string. It's string with a bunch of carbon going around it, like a tube with carbon in it. Now, carbon is a conductor, but it's pretty high resistance. You can see that the insulation is crazy thick. Why? Because spark plug wires are secondary wires, which means they carry a lot of voltage. Since they carry a lot of voltage, we got to have very thick insulation. Just like if we have a pipe, this one says schedule 10, and it's going to be thin wall. This one, these are pipes. It's going to say schedule 80, has a very thick wall. Well, this one's going to be rated at 600 psi. This one's going to be rated at like 125 psi. Because if you want to keep high pressures in, if you want to keep high pressures in, you got to have a big old thick wall. And voltage is electrical pressure. So as a result, our spark plug wire is not, we don't care much about the conductor because we're not traveling too much amps. But what we are doing is we're traveling a whole bunch of voltage, and we need to make sure that that voltage stays inside here and doesn't go somewhere where we don't want it to go. So we got super thick insulation, and you know, we'll go 7 millimeters thick, 8 millimeters, 9 millimeters thick. The greater the thickness of the insulation, the more protection we're going to have against this voltage going someplace where we don't want it to go. Because remember, what do we have to do in the ignition system? We have to get the voltage to come down this wire, jump across the center electrode to the side electrode, creating an arc and igniting the air-fuel mixture. If it goes anywhere else, we're going to have a misfire, a failure to combust, and we're going to be dumping all that raw fuel into the catalytic converter, which is why it's going to give us a flashing check engine light saying, stop driving now. Because if you don't, you're just going to be dumping more and more raw fuel into the catalytic converter, which is going to eventually plug the catalytic converter and kill it, right? Imminent engine or converter damage. So this is spark plug wire, coil wire, they're both the same thing. These are secondary wires. Ignition secondary are going to be like 20 kV to 40 kV. This is why they're so sensitive, so delicate. Well, first of all, this isn't even wire, it's plastic and string. But the rest of the part is because they're running this high voltage, as a result, they're really, really sensitive. Like you don't want to drop a oxygen bottle, right? So what do we do? Well, this is what we're going to do. This is fun drawing, actually. There we go. That's called a spark plug wire loom. And it looks like that, for instance. Sorry. See that? Now, people say, well, that surely keeps everything nice and organized, but that's not the main point. That is a good point, but it's not the main point. The main point is we're keeping these wires away from each other. Because if they get too close, they will start doing what's called crossfire, which is to say this arc is going to go down that wire. That would be terrible, especially if it happened during the intake stroke, for one thing. So as you can see, when we loom up the wires, they look very pretty and nice, but that's not the main concern with looming. The main concern with looming is to make sure that the voltage does not escape, the high voltage does not escape. Now, most people don't understand looming. They just think it's a pretty thing, and it's not. So as a result, what happens is, especially on older engines, like they'll break the looms and then they won't replace the looms. So now they just hold the wires together with a zip tie, cable tie. That's like almost the worst thing you could do other than holding it together with a piece of steel wire. Because anything you do that's going to make these things more conductive is going to be a bad thing. So let us look and make sure we understand why this is such an issue. Well, let me see here. Well, actually, I could come here and go like this. And I could go like this. All right, big block Chevy. Big block Chevy. And you can see that here's a wire loom here and a wire loom here. Sorry, and a wire loom there. And what it's doing is it's holding the spark plug wires exactly where we want them, and it's keeping them the hell apart because this is a very high voltage situation. Plus, what it's doing is it's keeping these spark plug wires so they're not laying on the exhaust manifolds, which will burn right through them quick because they're made of plastic. And as soon as the path to ground is less resistance going through the spark plug wire, I guarantee it's going to go through the spark plug wire. And that's bad because now you got a spark plug that's not going to fire. All right, let's one that one, this one, this one. This one. Well, this one isn't as bad, but what happens is as we go through these different situations, we're going to see, for instance, go to screen sharing, new share, sorry, this one. Pretty small block Chevy. And look, this wire is directly under the header, which is why you don't run headers. This wire is directly underneath the header. If it wasn't in looms, you'd be burning it. This wire is directly underneath the header, the exhaust pipe. If it wasn't in looms, you'd be burning it. So what the looms are doing is they're basically protecting the wires. All right, one more and I think we're done. I'm going to come here to paint. And I'm going to come to the beautiful screen share like that, like this, like this. Small block Ford. Now, right here's the ignition coil wire, going over here to the distributor cap. Coming out of the distributor, you can see that big old mess of wires right there. Look how freaking thick the spark plug wires are. That's cool. That's high performance stuff. That's much more expensive. But look, it goes into a loom right here, and it goes into a loom right here, and a loom right there, which is good because if it didn't have a loom, these wires would be laying on this freaking hot valve cover. And I guarantee you, it wouldn't take long before it burned its way through them. So we need to have looms. Looms are doing an important function. You'll notice this doesn't even have the, it doesn't have the exhaust pipes on it, so you can't see how bad the situation gets when you get hitters. But the looms are doing a really important functional problem, and it's not just a matter of looking pretty. Now, these are big old spark plug wires. Big old spark plug wires are expensive, but they're worth it. Because what happens is you're going to find out that 98% of the failures on these are going to be failure to install them correctly, or failure to install them correctly, basically. Because the way the factory has it set up, it's set up that way for a reason. And lots of people get lazy and they're like, well, I don't want to sneak it through there, so I'll just do it this way. No, don't do that. Don't do that. So do yourself a favor and you make sure you install them well, and then you won't have problems. If you don't install them well, you will have problems and you won't like it. So it'll let you down when you don't want it to. All right, so at the end of every spark plug wire, is this thing called the spark plug boot. Every boot does the same thing, right? Oh, shoot, sorry. There you go. At the end of every spark plug wire is a spark plug boot. See, it looks like this. That thing right there. And it's got that little electrical connector. You can see, it's harder than it looks. It's got that little metal connector in the bottom. You can see, there you go. So this is the boot. Every boot does the same thing. CV joint, whatever. Every boot does the same thing. It keeps what's inside in, keeps what's outside out. What's inside that boot is our beautiful, perfect spark plug that has to be kept beautiful and perfect. And it's delicate because it's high voltage. What's outside is grease, oil, dirt, all kinds of water, all kinds of conductive stuff that we need to make sure isn't going to screw with the operation of this spark plug. So every boot keeps what's inside in, keeps what's outside out. Okay, so what are we going to do? First of all, when we take this thing off, we're going to twist it off. We're not going to pull it off. Because what happens is every time voltage goes across the connector to the spark plug, there's going to be a little arc. And what that can do is it can weld the two together. So if you try to pull this boot off, it's like a stinger on a bee. You pull this thing off and the connector comes with it, stays with it. Now you need to buy a whole new set of spark plug wires. So here's what we do. We're going to twist it, not pull it, right? We'll twist it first and then pull it at least. But we're going to twist it first so that if it has welded together, it will release. Then we can pull it off. From here? No. You want to get spark plug boot pliers and grab it from there or wherever the first solid piece is. Now, Chuck will be the first to tell you that when we're putting this back together, well, let's see. I'm going to put the electrical connector inside here. You need to maintain that because you got to understand that no electrical connector is going to make a really solid connection with this. You can't solder to it. So as a result, if you pull on this, it'll come apart. Yeah, it will. Now, can you repair it? Well, maybe me and Chuck can, but you shouldn't, but we shouldn't. What we should do is say, we have been bad people and our penance is to go down and buy another set of spark plug wires for 50 bucks, right? Because if you try to repair these, chances are good you're going to wish you didn't. So the connector's made of metal. You can't have a real solid connection to this because it's just crap anyway. It's just string anyway. You're supposed to tie a knot or something. So here's what we're going to do. We're going to make sure that we take the boot off correctly. And then after we install the new spark plugs or whatever, we are going to install it correctly too. So it's going to go like that. It's going to go like this. So to install,
Can you raise the page a little bit?
sure, thank you. A pea-sized blob of that. How'd you know?
I think we taught this last week for some reason.
Yeah, we did.
Oh, okay. Good. Thank you. So good. Yeah. Thanks for, you got to let me know on this, folks, because we don't have time to do stuff twice. So yeah, that's what I thought. Okay. All right. Let's go to the next page then.
I don't think, did you talk about how it was installed though? I don't think you did. But we talked about dielectric grease.
Mm-hmm.
Right. So you just put a pea shape, not bigger than that, a pea-sized blob.
Yeah, you did talk about it. I'm sorry.
And And
That's
yeah, don't put too much or you won't be able to put the boot on all the way. All right, so let's go to spark plug wire testing. Because remember, this is supposed to be an intro class, so we're not supposed to go too far into it. Spark plug wire testing. Most failures, let's say failures, are going to be 1, excess resistance. And I'm going to give you that spec in about 5 minutes. That's too much resistance because these are resistor wires. The reason they make them out of carbon is so that they have a whole bunch of resistance. Well, why would we want a whole bunch of resistance? Well, it turns out we want a whole bunch of resistance because every time the spark plug fires, there's going to be a tap, 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 tap. And what the resistor wire does is it kicks up that sound so high that you can't hear it. Otherwise, it would be interfering with your radio. It's called radio frequency interference. It'd be going tap, 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 tap. And as you went down the road, it goes depending on engine RPM. So they use resistor wires and resistor plugs. That's why it's R45. They use resistor wires and resistor plugs to get the frequency of that so high that you can't hear it. All right. So the first problem is going to be excessive resistance. That happens. Number 2, opens. That happens a lot, especially, guess what? When people pull them off wrong. Number 3 is going to be insulation defects. How do we get insulation defects, children? We get insulation defects by not putting the freaking wires in the looms where they belong. And number 4 is bad connectors. How do we get bad connectors? By pulling on them in the wrong place. So these are, as you can see, technician cause, technician cause, technician cause. These are the number 1 cause of failure in engines is the freaking spark plug wires, which is why, see, back in the day, we used to say, oh yeah, this is the first thing I'm going to teach a technician. No, not me, not me. No, I'm going to wait a long time on this. I'm nervous about this. And I'm especially nervous about them putting spark plugs into aluminum heads. I'm nervous about that. I'm not just going to let some freaking yokel do that as their first project. It's too easy to do hundreds of dollars worth of damage. Things have changed. Okay. So my point was, there is a resistance specification for spark plug wires. They're not really wires. Wire resistance specs, specificaciones. That means 4K ohms per foot maximum, or 10K ohms total maximum. So it's got to be below that. So what are we going to do? You know what we're going to do. You know we're going to break out the ohm meter. Just like that. You got that? Now, when you're using an ohm meter, what's the first thing you're going to do? Oh, wait. Turn on the light. That light is freaking useless. Ah, there. That's not so bad. Okay, first thing we're going to do every time we use an ohm meter is put these 2 leads together. And we see that we got 3 ohms. Something wrong with the leads, but we're not going to worry about it because we're looking at thousands of ohms. Don't worry about it. Okay, where is my, where is my widow? There we go. Here's one. All right, this one's about 2.5 feet long, I guess. Yeah, about 2.5 feet long. So I'm going to take 1 lead. Remember, ohms is not polarized, so it doesn't matter which end I do. I'm going to take 1 lead and stick it in there. I'm going to take 1 lead and stick it in here. Ah. What do we got? Ah, Let's make sure we read this correctly because it's important. See that? Huh? That just makes it worse. See that? Now, here's the thing I need to point out. It says 1.107, and you say, oh, so it's 1 ohm. No, look, see that right there? It says kilo ohms, 1,000 ohms. So total resistance is 1,100 ohms, or 1.1 kilo ohms. Is that a pass?
Nope.
Yeah. Well, it's got less than 10 kilo ohms per total, right?
Mm.
This is max.
Mm.
So it's got to be less than that. Yeah. Okay. So that's a pass. In fact, it passes both tests. All right. So there is that one. Let me test this one. Now this one is 3 feet long. So is that going to have more or less resistance or the same?
More.
Yeah, it's going to have more because one of the things that determines the
More.
resistance of conductor is going to be length, right? So I put one side there and I put one side here. Ah, says OL. Put one side there. What the hell? Oh, down here. There we go. Well, it worked like 5 minutes ago. Damn it. Oh, where? There we go. 1.454 kilo ohms. Is that a pass or a fail?
Fail.
What? Look at the specs. No more than 4,000 ohms per foot. No more than 10,000 ohms total. This has 1,500 ohms. Is that a pass or a fail?
It's a fail.
That's what? That's a big time pass.
Oh.
Okay, look. Cannot be over 4,000 ohms per foot. Cannot be over 10,000 ohms total. Well, it's 15,000. It's 1,500 ohms. So that passes on both. So this spark plug wire is good. Yeah, that's how you do it. That makes sense. And we saw that the longer the spark plug wire is, the more resistance it has, which stands to reason. It's a resistor wire. It's not just wire. Now, could you replace it with wire? Yeah, but you're going to hear it on your radio, that's for sure. And there wouldn't really be any benefit to it because that much voltage you can blow through all kinds of resistance. Current
Question.
is not the issue. Wow.
So you're saying that when we see the symbol of kilo ohms is meaning under 1,000?
No, kilo ohms means 1,000 ohms.
Okay. So
So
we look for
1.5
that symbol on the meter.
Yeah. Yeah. Or the big capital M ohms is 1,000,000 ohms, 1,000 kilo ohms. Yep. Oh, shoot, it's 7:37. All right, you ready for 15? What would that be, 750? Yeah, let's make it 750, yeah? All right, thanks, folks. I'll see you in a minute.
Okay.
Anna Maria.
Yes.
So back to what we were talking about. You don't want to let the fuel system sit in the tank. So only use it when you're taking a long trip, and then use it with premium fuel for your first run. That's how I keep my engines clean in my cars.
So like, okay, so just because what I heard, if I wanted to like treat my system, I could either do premium or treatment. Would that be the same effect?
It's actually better if you do premium and for a long run, because that's what I do.
Mm-hmm.
And
But what I'm
that's
trying to
why
think, like regularly, if I'm not doing a long run, but I want to keep it clean, should I do a premium
you would
once a
run
month, or should I
premium
do it
or
and
once a month. Run premium once a month,
Got it.
because that won't
Okay.
harm the tank if it sits there for a little while. The fuel system
So it
cleaners
won't-
will actually eat away at the tank.
Okay, so like for instance, if I wanted to do that, so once a month premium seems better because I don't drive that much, you know what I mean? Like during the week, like my longest drive might be, I don't know, 10, 15 miles most of the time. So then if I wanted to
Yeah,
take care of my
so-
engine, that would be premium versus the treatment, unless I'm taking maybe a road
Yeah,
trip.
you'd want to
Okay.
do the premium instead of the fuel system cleaner,
Got it.
because
Okay.
the premium won't harm the tank if it sits in there,
Got
but
it.
the fuel
But the
system
treatment
cleaner
will.
will.
Got it. Okay. All right. That
So
helps.
if you like, for example, when my cars need a smog, I
Yeah.
put a fuel system cleaner, I fill the first tank with premium, and I drive to Quartzsite, Arizona and back.
And that's
by the
actually
time-
funny. That's the place I think I'm gonna take a trip to, Quartzsite. That's so funny that you say that.
Yeah.
Anyway, go
I
ahead.
like going there because one of my favorite jerky places is right there off the freeway.
Oh, wow. Okay.
So I like going over there and picking me up jerky and then driving right back.
Wow. Okay. That's a long drive for jerky, but okay.
I found the place one year when we were going to Williams, Arizona for a trip. I don't even remember for what. I think we were just going to the Grand Canyon. No, that was before we even found out about Polar Express. I think we're just going to the Grand Canyon for a vacation.
Cool. Yeah.
And
Yeah, I've been out
we
there
were
quite
starting
a bit because my son went to Flagstaff, Arizona for school, so I was out there quite a bit. So
yeah, we were getting hungry and we wanted a snack, and we saw this place that said fresh beef jerky. So we stopped in, and ever since then we always stop there and get jerky.
got it. Okay.
So that's
All right. Yeah.
that's my run to.
More than jerky.
That's good information because I was just talking to my son about that only because I think like my car's getting older and I want to make sure I take care of it and so forth. And we were just talking about that the other day. So
Yeah, for your daily activities like Monday through Friday type stuff, you'll want to only run premium once a month.
got it. Okay.
Um,
Yeah, that makes so now I
When
think
you
that
go-
clarified. That makes sense to me.
and when you go to do a long trip or like you need to smog your car, then
Yeah.
you'll want to run a fuel system cleaner and premium and burn the full tank out.
So I
Like
did,
I'm gonna
so
have
I
to
would do the treatment and the higher premium and then run the whole full tank and then do it.
Yeah, the way I do
Okay.
it, and this is how I get my 91 Ford Taurus to still pass smog,
Okay.
is I put a fuel system cleaner in, I fill it with premium fuel, I drive it all the way out to Quartzsite, Arizona. By the time I
Wow.
get out there, I have probably about a quarter tank left. I fill it up out there, I drive it all the way back, and I top it off just before I pull into the smog station. And then I get it smogged.
I ever tell you where I drive to get my car smogged? About 2 blocks down from my house.
Okay.
By the way, you're still recording.
Huh? Yes, when I'm not too busy.
Well, I don't think I don't think I'm ready for smog. I was just thinking like overall in general because I'm thinking, oh wait, my car, how many miles does it have? It's getting older. Let me be smart about
Right, sober up. So anyway, Gabe, what we were talking about is freaking construction workers leaving screws all over the streets and popping 3 of Anna Maria's tires. Would you like to apologize now, or would you just like to send her a check?
Oh my gosh. All I'm gonna say is I am sorry, but it definitely happens to my own work truck as it is. happens to my own work truck. In fact, I was at work one day, and then my work truck has the 6 tires on it. So the back, the outside ones, anyways. So I show up to the job site, and my coworker's like, "Hey, you got a flat on one of your back tires." And I'm like, "No, I don't." He kicks it, and that thing just bounces right back like nothing. And I was like, "Oh, dang!" And always big old huge construction, screws. And it's like, and as some construction guys, like when they're looking through all their tools or they're opening up their bins and everything, like I'm always mindful of that, to always see and pick up all my tech screws, every kind of screw that I drop. And when I drive off, I look around my work truck also. But I mean, it's almost inevitable. It's almost inevitable. Like, just whenever you guys see or work around any kind of construction or see any kind of work truck around your vehicle, always look around to see if there's any screws on the ground. Always.
No, it was just Anna
Let me
Maria giving you your
tell you.
screws back.
This is a big intersection on Baseline and Day Creek. I've been avoiding that spot because I've been seeing some stuff running around there, and my son already got 3 flat tires. I don't need one. Anyway.
Yeah, it's just Anna Maria giving you your screws back. All right.
No.
spark plug
Yeah, I'm
in-
going to charge you.
Yeah, right. Yeah, I was just glad he didn't ask for his screws back. The point I was trying to make was spark plug instalaciones is all about cleanliness. Why? Because we are dealing with very high voltages, and if you aren't careful, you're going to get grease and oil all over the porcelain, which will turn it from a insulator into a conductor, and then it ain't going to work right. So always wash your hands first. It's like putting brakes together. We're going to use clean hands. Now, the porcelain of the spark plug must remain an insulator. And if you get greasy fingerprints all over it, those are conductors, because grease and oil have carbon in them, which is a conductor. So, number 1, clean your hands first. Actual 1A, I guess, is always check and adjust spark plug gap. Why? Now you go to Craig and O'Reilly's, whatever, they're going to tell you, oh, these are already pre-gapped. You don't have to worry about that. No. Always check the spark plug gap. Using what type tool? Feeler gauge, yeah. Go down to Harbor Freight, whatever, get your $4 feeler gauge. You'll be fine. And it'll last the whole rest of your life. And you'll always have the perfect spark plug gap. Now, some spark plugs you can't gap, but the ones that you can, you need to gap them. Why? Because maybe they dropped the box. You don't know. And the thing is, once you've installed the spark plug, now it's a big old pain to get it out. So we want to make sure that it is installed perfectly so that we don't have to worry. So if something ends up being wrong with it, we know it's not the spark plug. Okay, so always set the spark plug gap perfectly. They call them feeler gauges for a reason, so that there's a slight drag when you pull the thing out. And protect the porcelain from all enemies. That's what I said. Protect the porcelain, which is on both ends of the spark plug, from all enemies, foreign and domestic. What are the enemies of the porcelain? Well, there's chemical enemies such as grease and oil. And there's also the physical enemies such as putting too much side load on the porcelain. Did we show you that last week?
Yes.
Yeah. Okay. So clean hands only, folks.
Is there anything that can protect the porcelain
From chemicals? Yeah, clean hands.
besides clean hands?
Colgate.
Nah.
No.
Now,
Joking.
now, did we talk about putting anti-seize halfway down the threads?
Yes.
Yeah, that's what I thought. So that's the way we're going to protect the porcelain on the inside of the spark plug. On the outside, we just got to use clean hands. Don't get paranoid about it, but it's just most people are using greasy fingerprints, and as a result, they cause their own failures. I mean, most of the secondary ignition system failures, should I say it? Well, let's just say many of the secondary ignition system failures, the high voltage side, are going to be technician caused errors just because people think it's a really easy, simple thing to do. And it's, it's kind of involved. Like
So
people,
does the porcelain kind of act like the way the halogen lamps are? Like how you get your fingerprints on the halogen lamps? Is that the same kind of deal?
no, okay. On the halogen lamps, what happens is the oil in your fingers starts to boil and it pops the bulb. What the purpose of the porcelain is to act as an insulator. So if you coat it with a conductor, now it's not going to work as an insulator. And we're dealing with insanely high voltages, like 40, 50,000 volts. As a result, it's just looking for an excuse to jump somewhere other than the spark plug gap. Okay, so we need to make sure that the path to ground for all that energy in the secondary of the ignition coil is the lowest resistance path to ground is across the spark plug gap. And that's hard to do. I mean, you have to maintain the integrity of every inch of that secondary ignition system to make sure that happens. So that's why the secondary, spark plug wires are so delicate, fragile, whatever you want to call them, and so vulnerable. So grease, oil, all that stuff is just an accident waiting to happen. Now we talked about cross-threading too, right?
Mm-hmm.
Can I add one more thing, Mr. Rocliffe?
Yes, please.
Yeah, a lot of these new cars, they have the spark plugs where they're deep recessed inside the valve cover. And a lot of times when you pull a plug, you see them filled up with oil because of the valve cover gaskets are bad.
Right.
That's a big mess right there.
Yeah, absolutely. Sure. Yep. So just call Chuck Ring Automotive. Get your discount coupon for Sancho's birthday. All right. We talked about not removing spark plugs from a warm engine.
Yes.
Yep.
Okay. Now I'll show you the video, but I'm not going to show you the video because we don't have time, but I'll show you the name of the video. How's that? Not you. Not you, and not you. Not you. How about that? Well, we'll go to screen sharing is pause, new share.
Kitty.
Oh. There we go. So the video that I would like you to watch is this guy fixing strip spark plug hole in an aluminum head. The name of the channel is Cheap Homesteading. And it's a good video, but he's Canadian, but still. So he's fixing a hole in a Honda Odyssey. There's a couple of things I would have preferred he had done differently, but it's a great video, actually, I think. Now, this guy is slathering. Let's see what Chuck thinks about this.
Did you hit record already? You did, huh?
Yes, sir. Yep. Okay. So I'm going to come in here. Like he's blowing all these chips out of the hole. This is nice. Okay, so he's blowing all kinds of aluminum chips out of the hole. This is exactly what Chuck was talking about, these towers. Now he's got aluminum chips all over the inside of his engine. All right, check this out,
One
Chuck.
of the spark plugs. You screw it all the way in.
Look how much Loctite he uses.
You get a little Loctite.
That's not a little Loctite.
Put it on the thread. So we stick it through here.
It's like he used half the bottle, right? And he's doing that on a brand new spark plug. So the chances of fouling that brand new spark plug with all that Loctite, I think, are very, very large. So I don't really think that's a great way to do it, but what's all this shiny silver stuff all over the inside of his engine? Oh, that's aluminum chips. Nice. That's okay. It'll just go to the oil pump pickup. It'll stop it. Maybe, probably.
Yeah, it's no big deal. I mean, it'll get picked up by the oil pump. It's fine.
Well, you know what the aluminum does? It'll build up the clearances between the bearing and it'll fill in the clearances between the bearings and the journals. So it's all good. Anyways, but other than that, it's pretty good video. I mean, there's free. Oh, South Main Auto Repair's got one, but it's like 50 minutes long. So there's a whole bunch of videos like that where you can probably figure out how you want to do it. You know, there's a million videos about all this stuff. Oh, not that. How about that? That is dielectric tune-up grease. That is anti-seize right there. Just so you knows. And I think that's about, oh yes. Oh yes. That right there is an LS motor. That's hooker header. Hooker headers looks like that. Those aren't even lengths. Right there is the water pump right there. And we have the 1 coil per cylinder. And we see that it does have a spark plug wire, but it's very, very short. In fact, it's so short it doesn't even need a loom. Now my question to you is, what does it mean when a bolt has a number on the top? 8.8. This one says 10.9. What type of bolt is that?
That's the strength of the bolt.
That's a metric, right? That's how metric bolts show you the strength of the bolt, right? Chuck's absolutely correct. If they were SAE fraction of an inch, they would have lines on the top to tell you how strong they are. But these are metric, so they say 8.8, 10.9, whatever. And I need to tell you that there's a coil there, coil there, coil there, coil there. So that's how we're addressing the problem of having 1 coil supplying all the cylinders. We're going to have 1 coil per cylinder. This is the next best thing to coil on plug. But they had to do this because as long as they're running this type of combustion chamber, which they saw a good reason to do, you couldn't fit a coil in this tiny hole. So they had to run it this way. But you're not going to have any problems, I don't think, arcing from these spark plug wires to any other. I mean, there's not a huge reliability problem with these spark plug wires because they're so freaking short. And they're not coming close to anything. They're not being routed around anything. There's pretty much a straight shot from the coil straight to the spark plug boot. Well, while we're on that topic, let us talk about the final type of ignition system.
Is that a knock sensor or a water sensor?
This right here, I believe, is a water sensor because aren't there knock sensors underneath the intake manifold? There's 2 of them. Yeah, that's what I think. Although, I don't know why the water jacket sensor would be here. I mean, you would think, well, because it doesn't have the thermostat housing's way over here and it's not at the top. Oh, it's a reverse flow because this water pump's pulling in from the top. I guess. I don't know. I'd have to look at it, but that's off the top of my head. That's what I'm thinking. I know it's got a carburetor, which doesn't seem right. That's a General Motors intake manifold, though, which is weird. Who knows? Here's what I do know, though. The final ignition system is called coil on plug, but not hop on pop because that's racist, of course. Oh, did I show you this? That right there is a camshaft position sensor. You see it's got 2 leads. Yeah, it doesn't look like a pickup coil, but that's what it is. That's how it runs. This right here is the coil off a distributorless ignition. That's what I wanted to show you was coil on plug, just like that. And that right there.
Ooh.
That's breaker point ignition. Yeah, like finally an ignition system I've worked on. Yep, that's breaker point ignition. That's where it hits the rubbing block. It's all worn out. So this is called coil on plug. As you can see, it's got a coil on top of the plug, which means it doesn't have a spark plug wire. If you wanted to call anything a spark plug wire, it would be about 3 inches long, which is shorter the better. This goes right on top of the spark plug because this part goes, the spark plug goes in that. And you'll notice that the only wires going to this coil are primary wires, 12 volts. So it doesn't have spark plug wires. It doesn't have high voltage wires. What it has is 12 volt wires going to the coil, which is groovy because we don't have a problem with 12 volt wires. We don't have problems with leaks and all that other stuff. These are high reliability, and as a result, the ignition systems have become relatively trouble-free ever since we went to number 4, coil on plug. Cop. Oh, Chuck, the power probe you're talking about that does the graphing is called the Maestro.
Oh,
It's
yeah?
like, yeah, it's called like, it's like $400. That's why I didn't get it. But, oh, be sure to bring the case for the power probe when you come, and I will give you this case that came off of the Power Probe 4.
Okay.
That's how you want to do it. That's how I would suggest it. Okay, so that means only wires running to the coil. Coils are primary wires, 12 volts. We don't have a problem with 12 volt wires. And as a result, our reliability issues have gone away pretty much completely. Now they're just as reliable as any coils. Now, here's the big question that I wanted to ask you. I have an 8-cylinder engine with 8 coil on plug coils. One of the coils go bad. Do I replace all the coils?
Wait,
What's
can you
it what?
repeat the question?
I have a V8 engine that has coil on plug. One of the coils goes bad. Do I replace them all?
No.
No, no way. I mean, these should last 300,000 or 400,000 miles, right? So if one of them goes bad at 80,000, I'm going to say manufacturing defect, something like that. But I've seen Corvettes, for instance, for sale on OfferUp where they said all 8 coils were replaced 10,000 miles ago, and it's like, damn, you must have paid a fortune for that. I mean, if you get a screw and a tire, are you going to replace all 4? If you have all-wheel drive, you might. Yeah, that's another reason not to get all-wheel drive. But in general, no, you're not. If you so let's say let's say your right front tire brakes go bad, are you going to replace all 4 wheels? No, you just replace. I'd probably replace those. I would replace the brakes on that axle, but I wouldn't replace all 4. Right. What we have to do is we have to understand enough about cars to understand, well, what's really worth replacing and what's not. Now, if I have a bad spark plug, I'm going to replace all 8. Yeah, that I am going to do. But in terms of replacing all the coils at the same time, okay, for instance, fuel injectors. Fuel injectors are usually hard to get to. So if I'm going to take the things apart, well, maybe I'll consider replacing. What do you think about that, Chuck? Are we going to replace all 8 fuel injectors while we've got the...
No. For me, of course, you're going to ohm test them. Since I have an ultrasonic cleaner, I'm going to buy a kit, the O-rings, and I'm going to clean them out first. And then again, also whatever the trouble codes are telling me, what particular cylinder or misfire, that's the one injector I'm really going to focus on. I may replace that one. But changing all of them, that's depending on the car, it could be a pretty big pill to swallow, a tough pill as far as cost. So unless the customer says change them, I'll change them. But it's my car. I'm gonna go the extra mile just to see, out of curiosity for knowledge.
Yeah, yeah, I mean, you're right, because I mean, injector costs 60, $80. I mean, replacing 7 of those for no good reason, that's well over $500, and that's not even, that's just for parts. Yeah, okay. Yeah, so I mean, the reason I bring this, okay, for instance, if a shift solenoid goes bad in the automatic transmission, you're going to replace all the solenoids? I don't think so. Now, if you're a professional rebuilder, you probably would, just because the warranty is like huge. You know, you're gonna have to dump a whole bunch of fluid. That's for sure. Like an Allison, yeah, they're gonna replace them all. In fact, every rebuild, they're gonna replace all those solenoids. That's why it's like $1,800, $2,000 just in solenoids.
Mhm. Yep.
But they won't warranty them any other way. All right, ¿qué más? Okay, coil unplug. So now we got 1 coil per spark plug. We got an insanely fat spark. If we're ever wondering if we're getting spark out of the coil, we can always pull it out and put a number 2 Phillips in it and go towards a good engine ground and see if we got spark, just like we did with the old spark plug wires. Coil unplug takes less time to teach than every other system because it's so obvious. Okay, how do we know when to fire it? Crankshaft is in sensor, camshaft is in sensor. You know, it's obvious, and it's the most intuitive system of them all. So that's what I'm happy about. What else we need to talk about when it comes to ignition systems?
You were gonna say something about the valve cover gaskets or something last time.
Well, that's what Chuck was talking about. There's these
Okay.
tubes that come out from, okay, when you have a hemispherical combustion chamber, when you have a hemispherical combustion chamber, which most, for instance, Asian imports do, but most cars do actually, you got the valve cover that comes like this, dual overhead cam, for instance. And what they're going to do is they're going to have a little tower that you put the coil on plug in. Sure. Ah. Oh. Okay, so this intake and exhaust, whatever. Hemispherical combustion chamber. And then you've got this little tower that the coil on plug thing goes to. And it's got to go down inside this little tube. Well, in order to get a seal, they're going to have these little O-ring looking gaskets. Actually, I'd call them seals, but however you want to go. And there's going to be one of these for each one of the holes where the coil on plug goes. If these start leaking, what happens is the oil gets inside where this thing is and often cause a misfire. If you're going to replace the plugs, or if you pull this out and it's wet, you need to come in here and replace this, and you might as well replace the outside gasket while you're there, because that has to be dry. Or it starts doing exactly what happens when we install stuff with dirty hands. It just starts conducting where we don't want it to. And that can beat stuff up pretty hard. So don't do that. That make sense?
Yep.
Yeah. All right, Chuck, what else we need to talk about when it comes to ignition systems?
The reason I kind of cry about that graft is that every once in a while, you'll get a coil on plug where you get a trouble code says misfire, but doesn't actually tell you which coil is bad. So, you know, you either kind of guess what bank is from, and you maybe want to switch coils from one to another, see if it shows up on the scanner or not. The coil on plug is better, but sometimes not foolproof. I mean, it can give you little gremlins, you know what I mean?
Yeah.
By having the analyzer, you could kind of put it right over the coil and see the graft, you know.
Right. Yeah. Yeah. Yeah, that's nice. Now, what Chuck's talking about is a troubleshooting technique. When you have coil on plug, you got a coil for each cylinder. And let's say you're having a misfire in cylinder number 4. Well, what Chuck's talking about is let's take the coil off of cylinder number 6 and put it where number 4 was. Let's take the coil out of cylinder number 4 and put it where coil number 6 was. Hook them back up and start the car. and see if the misfire follows the coil or it stays on the cylinder. That's going to tell if the coil's bad. If the misfire moves to cylinder number 6, then we know the coil is the problem. If the misfire stays on cylinder number 4, we know the coil isn't the problem. Put it that way. What else could it be? Injector? Could be some kind of rings or valve issue. Anything like that, yeah. There we go. Good. All right. Well, I would suggest that we should do history of emission controls. That would be a smart move. If you're ready. I mean, Chuck, if you're figured we're done with ignition systems, I think we are. Okay, so emission systems, emission controls, right? Here's the thing. There's 3 smog gases that we worry about. That's HC, CO, and NOx. That's hydrocarbons. And fuel and oil are hydrocarbons. So if we have high HC emissions, that is, unless we got a real oil control problem, that's going to be unburned fuel. CO is carbon monoxide, and that is partially burned fuel. So it didn't go all the way through the process, usually because of air fuel mixture. Now, those were the only 2 that we worried about for the longest. And what we in general, if you have unburned fuel emissions, we saw that as a problem usually with ignition systems. Why? Because spark plug doesn't fire, you're not going to burn the fuel. If we had partially burned fuel, that means that something was wrong with the air-fuel ratio. So we would say that that was an air-fuel problem. In general, that's the way to bet. Now, everybody was having a great time. 1969, All Day Music came out. All my friends called me lowrider. Everybody was sitting in the park waiting for you. And then we had like 450 horsepower in our 454s. Everybody was so happy. Everybody loved each other. And then we started worrying about NOx, oxides of nitrogen. Now it's called NOx because we don't know whether it's going to be NO3 or NO4. But oxides of nitrogen are created by high combustion temperatures. Well, guess what causes high combustion temperatures? High compression. So then we lost out on all our high compression engines. And guess what happens to the power that comes out of an engine when you run the compression down from 12 to 1 to 10 to 1 or 9 to 1? Yeah, you lose about 30% of the engine power. So this is what really killed the muscle car era, is this right there, caring about oxides of nitrogen. Because we went from 450 horsepower 454s in 1970 to 185 horsepower 454s in 1973. Now, here's the thing, 185 horsepower out of a 454, it still drinks gas like a 454, but it puts out power like, well, less power than a 4-cylinder does these days. And this is when the Asian manufacturers got to come in and say, okay, well, look, we'll make a car that's way faster. We'll take a 4-cylinder engine and we'll run it way faster engine RPM, and we'll make just as much power. So what was happening was we were getting like these big old station wagons that could barely go up a hill, and everything had 454s in them. So they were getting like 8 miles a gallon on a good day downhill, and they still couldn't tow anything. This is when GM really lost the loyalty of the American consumer, because all the different domestic manufacturers just said they'll never quit buying our cars. We can put together anything we want. But the cool thing was when I went to pick apart, man, every car had a 454 in it. It was like, yay, all these spare parts for me, which was, those were good times. The parts we used to find. Anyway, the point I was trying to make was these are the three main combustion gases, emission issues that we have on vehicles. And how we deal with these emissions is going to inform why we have the systems we have. So let's see. Number one was the road draft tube. And the road draft tube was primarily there for blow-by. And blow-by is combustion pressure that gets past the rings. Okay. So when pressure from compression or combustion gets past the rings, where does it go? It goes into the crankcase where the oil is. Okay, so then what happens? Well, then you've got all this vaporized or atomized oil inside the crankcase. That's where the crank is. And what was happening was it was pressurizing the crankcase. Well, we don't want pressure on the back of the pistons, so we put in vents. Okay, here's the problem. When you put in those vents to allow that pressure, the blow-by pressure, to get past the rings and keep from pressurizing the crankcase, it was pouring out like an aerosol of oil. Oil is a hydrocarbon. So in order to stop this from happening, what we were doing was we'd have side view, fan right there. There's a valve cover right there. And what we did was we ran a tube down to the bottom underneath the car from the valve cover. And we'd run this under the bottom of the car. So as the car drove down the street, it would actually suck gases out of the crankcase. But you can see that that's no emission control at all. That was just a solution to the pressurized crankcase problem. Pressurized crankcase would do things like create ring flutter, where the rings would actually go like this. That was no good. We'd lose our seal. So this thing would just be dumping all oil all over the highways. Now, in terms of asphalt, it worked great on the asphalt because it kept refreshing it all the time, but that was no good. So the first thing we did was we created what was called positive crankcase ventilation. PCV. And what that meant was we're no longer going to allow this stuff to just vent to the atmosphere. Now we were going to do something about it. So let me show you what we did about it. Got that? Okay, so we've got this valve cover here. Use a V8 just because it's easier. Got a valve cover right there. And what we're going to do is we're going to put this valve right here, one-way valve, but it's also got a valve in it. And we're going to run this thing over to, here's the carb right here, carburetor, old school. And we're going to run it down here to engine vacuum. There we go, something like that. So flow goes this way. So now what happens is when we get pressure in the valve cover, what's going to happen is that aerosol oil is going to come in and it's going to go into the intake manifold where it will be taken to the cylinders and burned. Over here, we've got a breather. Sorry. Which is basically going to run to the air filter housing usually. And airflow is going to go this way because after all, you have to replace the air that's going in here with fresh air. A lot of times you're going to see a little filter up here. Sorry. You're going to see a filter up here in the air filter, like on the old Fords. Used to get dirty all the time because when you lost oil control, you'd pressurize the crankcase so hard that it would actually reverse. Okay, so this is the PCV valve. And what the PCV valve did, since engine vacuum was really strong,
Valve enough.
what the PCV valve did was keep this from just flowing tons of air all the time. So what it did was, every valve controls flow, right? What it did was it made it so it only flowed when there was significant flow to be had. Otherwise, it would have emptied all the oil out of your engine in, a couple of thousand miles. So we use this system. In fact, do we still use the system? Yeah. 40 years later, 50 years later.
Yes.
The system starts about what, 1964, something like that? It was the first emission control system. And what we were trying to do is we were trying to just quit from dumping all these hydrocarbons straight out in the atmosphere. Now, you see that we're dumping aerosolized oil into the intake stream where it will be burned. That's got problems. And the reason it's got problems is what's going to determine how much pressure you got in your valve cover. That's going to be determined by the state of your rings. And the problem was back in the olden days when we didn't know crap about how engines operated or how to design them well, about 100,000 miles, your rings would lose control and you'd get tons of blow by. And what it would end up doing is it end up just blowing a ton of aerosolized oil in here, giving you oil consumption problems. And also fouling up, plugging up this valve, which is supposed to have a metered orifice, which means it's supposed to have a limited ability to flow. And when you stepped on the gas really hard and engine vacuum got low, what would happen is the pressure would go backwards and make this little breather filter all filthy. So the problem we were having with the PCV valve was really that we weren't any good at building engines. Because if your rings lose their ability to control pressure or oil, your PCV system is going to not work well. I strongly suggest don't clean these. You can clean them with brake cleaner. You can clean them with throttle body cleaner. I suggest you don't because they're like $7. And if you have a car, if you just bought a used car that's got one of these, I'd replace it. At least that way you know that it's flowing correctly. It's got a valve on a spring. So that was the first system. What does it do? Well, it keeps us from dumping oil on the street. So that's got its own beauty. So what comes next? Well, we started worrying about tailpipe emissions. So what we did was we said to ourselves, well, okay, the combustion process is, oxygen and fuel and heat or spark, but there's too much unburned fuel left over in the exhaust. Why? Because we weren't any good at building engines. Plus, we had carburetors, so the air fuel ratio was like who knows where. On a hot day and cold day, uphill, downhill, high altitude, low altitude, humidity, dry day, it would all be different. So what we started doing is we started taking number 2. That would be air injection reactor, CAIR, sometimes called secondary air. So what we're going to do is we're going to take the exhaust manifold, looks like this. What? That's the exhaust manifold. El múltiple de escape. So we got too many unburned hydrocarbons coming into the exhaust manifold and then going out to the atmosphere. We finally hooked up a gas analyzer to the tailpipe and we're like, what the hell is this? 1966. And what we're going to do is we're going to put a pipe going into each exhaust manifold. That's interesting. I just thought of this. It's very similar to the fuel rail. And what we're going to do is we're going to blow air into the exhaust manifold. Why? Because it's hot enough that the extra oxygen will actually burn some of the unburned hydrocarbons in the exhaust. So we're going to have what's called a smog pump. And that's going to be a pump right here, run off a pulley, so off of a belt. And that's going to pump air into this rail. Well, there's a whole bunch of really hot gas in this rail. So one thing we have to put in here first is a one-way valve. So flow can only go in this direction. So we can't have reversion. Oftentimes what happens is this one-way valve goes bad, you get hot gases going in and it kills the pump, it melts the seals out. That's why we got to check on stuff like that so that we don't just replace the pump and then kill the new pump in a month. So always check this one-way valve, make sure that it is working correctly. Okay, well, mechanics hated this because it's got all this plumbing over here, right where the spark plug wires were, right where the spark plugs were. So now all of a sudden, instead of having the free and easy access that we used to have to fix cars, we had all this freaking plumbing in the way. And that's when people really objected to the emission control equipment. Couldn't really do anything about it. They made it illegal, so we were kind of stuck with it. But that's when the resentment built. And the people that didn't loom their spark plug wires correctly soon found out why you should have, because it would just burn the spark plug wires. You'd burn your hands like hell doing this. I mean, it was terrible, and it basically took a lot of the fun out of working on cars. That's the big reason why most people went to headers, is to get rid of all this crap. Okay, so we're blowing air into the exhaust. Now you say, don't you need spark? No, because that's really hot. To burn leftover HC, hydrocarbons, unburned fuel. So already people are not happy about this. You shouldn't be. But that's what most of us remember, because this is what infuriated us the most. Now, do you think you can run the pump without losing horsepower? You can't. So we started seeing, a cost to these emission control systems. Number 3. Transmission controlled spark. TCS. This was on the GMs at least. So it said no vacuum advance in high gear. Why? Because the more advanced you have, remember, this was a NOx thing. Maybe I should write that down. So that's a NOx. This is a HC. Sorry. In 1970, we all of a sudden started caring about NOx. And what it did was it made it so we wouldn't get vacuum advance. Well, vacuum advance is going to increase combustion temperatures. Remember, oxides of nitrogen are created by high combustion temperatures. That's why diesel motors have such a problem with this emissions. That's why they've got this whole emission system just dedicated to NOx emissions. Because, you know, the compression pressure on a diesel is twice as high. It's going to have way higher combustion temperatures. Therefore, it's going to put out all kinds of oxides of nitrogen. All right, so people are angry about this because, first of all, they didn't understand how vacuum advance works anyway, but they could see that, well, the whole point of vacuum advance is part throttle fuel economy. So as a result, you'd start losing gas mileage. And this is when people started resenting emission control systems, because you would get worse performance and you'd get worse gas mileage, and the car would be harder to work on. And, you know, there's no OBD. So you actually had to figure out how all these systems worked, and so you'd have to get professional service equipment. You couldn't just like use the techniques you learned on Grandpappy's tractor. All right. There we go. Now, number 4. Catalytic converter. Now you're going to piss people off. So this is going to be HC and CO. So this is going to use platinum and palladium, sometimes rhodium, I guess, to convert HC and CO into H2O and CO2. H2O is water, CO2 is carbon dioxide. Back before carbon dioxide became the thing that made Mars get hot. It's too bad it's too bad there's not something that Mars and Earth have in common that would lead to both of them raising and lowering in temperatures. But it would have to be on the order of magnitude of a huge ball of fire in the sky. That was a joke. Anyways, my point was, but here's the problem with the catalytic converter. You can't have lead and still run a catalytic converter, because all the platinum and palladium will get coated with the lead. So now we say must use unleaded fuel. So now people are really pissed because the lead in the fuel made it really, really cheap to increase the octane. You know, we were running 100 octane straight out of the pump all day long. So it was very easy to have very high compression. Now, when I said that 454 had 185 horsepower, that's because it had 8.5 to 1 compression. Sucked. It's like lawnmower compression. When it used to have 12, now it has 8.5. That just made it a total dog, but it still drank fuel like a 454 though. So it had that going for it. So now the catalytic converter is going to be expensive as hell because it's filled with platinum and palladium, which are way more expensive than gold. And it's going to create a significant restriction to the exhaust, which means that's going to kick your performance in the butt too. And now you got to use unleaded gas. So now people are getting pretty furious. And they're starting to get away from these big old cars. And the domestic manufacturers misread the market. They thought that people would always want the big old cars, and that's true, they did. But you know, when the price of gas doubled in 3 months, I remember that was what, 1974. Arab oil embargo. Oh, if I say Arab oil embargo, is that racist now? Oh, God damn it! That's it. That's it. Okay. Yes, you can teach, but you have to never say anything. My point was the price of gas doubled from like 29 cents to 54 cents. It was 58 cents. It was devastating. Quack. That's true. So now there's all these extra expenses involved with emissions controls. Although I'll tell you, 1969, Southern California, I was in kindergarten and the air was freaking brutal. We used to have first stage smog alerts all the time. Brutal smog. It also snowed in Glendora that year. I do remember that. But probably not because of the smog. Anyway, we used to have first stage smog alerts where they wouldn't even let us outside to play in breaks. It was terrible. So the air is a billion times better now. Of course, you know, we're adding like $5,000 to the price of every car just on emission control systems, but you know, and we're a lot better at what we do now. But this is still using the old archaic engine designs because we didn't know any better, right? We hadn't really taken it seriously because, you know, gas was cheap and we had other things to worry about, like peace with honor. Ah, Nixon joke. You like that? Sammy too. I'm so old. Oh my God. Anyway, my point was, yeah. So anyways, now catalytic converter, which means you can't run headers anymore without a significant amount of plumbing. So people see that their freedoms with their automobiles are being squashed and squashed and squashed and squashed. Plus, these weren't really, I mean, we didn't know how to make them very well. And as a result, we were having a lot of failures, a lot of early failures, and it was annoying for people, and we didn't have good reliability. And as a result, people were very, very resentful of this. And it was really killing the performance of cars because we didn't know what else to do. I mean, there's a bunch of restriction in your exhaust. I mean, it's like someone sticking a potato in your exhaust pipe, and we didn't know what to do. All right, number 5. Here's the thing. You start messing with a man's advance. They had what's called lean burn. Ignition. Well, this is when we started having high energy ignitions because we wanted to increase the spark plug gap. Hopefully that's going to fix it, right? Didn't turn out to do too much good, but it did do us a little good. And it got us the high voltage that we wanted in our ignition systems. So the spark plugs would last longer, but it made the system more expensive. And you can see, you know, a Hemi Cuda was only like $3,000 or $4,000. So, you know, a freaking F-250 is what, 60 now?
On a good day.
Yeah, with a tailwind. Because what you can see now is lean mixtures. And what do we say about lean mixtures? Lean mixtures had problems with power. Lean mixtures have a problem with detonation. So now primarily American cars, we're really running like crap. And what were we trying to do with lean mixtures? Well, we're still trying to go after HC and CO. We figure if we put less fuel in there, that we'll get less fuel coming out the tailpipe. We're still focused on exhaust emissions now. So we ran higher voltages in our ignition, bigger spark plug gaps, because we're trying to burn this lean mixture, which the lean mixture does not want to burn. Lean mixture means it's got less fuel than would be ideal, I guess is what you would say. And now we're starting to mess with the carburetors, trying to run these things lean. That causes all kinds of drivability problems because you can run significantly rich without causing any problems except, excessive fuel consumption, which nobody counted in those days anyway. But you run just a little bit lean and you're going to have all kinds of drivability problems. Lean misfires, stalls, stutterings, stumbling. So this was the era when we started dealing with running lean mixtures, and it was pretty much a freaking disaster. Okay, number 6. Electronic carburetors. What a freaking nightmare these were. So we had carburetors, basically the same thing you've got in your lawnmower, but what we started doing is basically this is a very primitive fuel injector. That's exactly what it is, a very primitive fuel injector. This was where I learned pulse width back in the mid 70s. I didn't learn it till the 80s, but that's the system I learned it on. And basically what it was acting just like a fuel injector in the middle of the carburetor. We had everything on the carburetor, but we also had a mixture control solenoid in the middle that was pulse width modulated. Freaking sucked. But electronic carburetors led to oxygen sensors. So we can see that we're starting to enter into the era of electronic engine controls. So it ended up being better, but at the time it sucked because this was OBD none. Who knows why this car doesn't work right? Why do you think there's none of these cars on the road anymore? Because we got rid of them as soon as we could. And if you do see a 1978 Cadillac, first of all, if you see a car that old, it's got to be a lowrider. And even if it is a lowrider, it ain't going to have the original engine in it or the original, equipment in it because nobody knows how to fix that stuff. So now we're going with oxygen sensors. Now everything's really electronic, and the technicians of this era have to decide whether they're going to stay in this industry, because this is stuff you're not going to understand if you don't go to school, I don't think. Not most people. They're not motivated enough. Plus, this was OBD none. Plus, we were very, very primitive. We didn't really have good designs, and we sure as hell didn't have good troubleshooting diagnostic skills. So as a result, these cars got a horrible reputation for being unreliable, gutless, all this kind of stuff. And we would try retarding the timing. Okay, low power. And, we had carburetors, which were mechanical, which were only approximations of correct air-fuel ratio. And we also had distributors, which were only approximations of correct ignition timing. As a result, the cars ran like crap. My dad's brand new 1980 Buick Regal, you stepped on the gas, it would go bap, 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 pinging so bad. The jackass president of General Motors said the ping is the sound of maximum fuel economy. He said that and let somebody else hear him say it. Because what he was saying was, that means you got maximum spark advance and you've got the leanest mixture you can go. But we used to drive it around, and my dad's friends would be like, is there something wrong with your car? No, it sounded like that the day you drove it off the lot. Freaking sucked. V6 Regal, these cars sucked. But everyone now, they're like, oh, they're all sentimental about them. No, these cars sucked. Brand new, they sucked. So what was happening in terms of emission controls is we kept trying to run leaner mixtures. And the leaner mixtures, we couldn't get the power out of them. And we retard the timing, we couldn't get the power out of that. Okay, so where are we at? Now, we went to throttle body injection, we went to port fuel injection. So we're starting to get our performance back because we're starting to get smarter about how to run things. But they said, nope, here's the next thing that's going to suck for you. Evaporative emissions controls. evap system. Because what they noticed was now most of the emissions aren't coming out of the tailpipe. We've already taken care of that with the catalytic converter and lean mixtures and stuff like that. Now most of the emissions are coming out of the fuel filler neck and out of the carburetor, because we had float bowls in the carburetor that were filled with gasoline. That's on top of the intake manifold, which is a hot part of the engine when you turn off the engine. And what would happen is you would stop the car on a hot day and all the gasoline in the float bowls would evaporate and it would get vented out to the beautiful sky, and you could see all these rippling waves coming out from the top of your hood. Similarly, the same thing was true with the filler neck. The gas caps we used to have didn't used to have this seal to it. So you would just walk down the row of cars at Montclair Plaza, and you would see all these ripples coming out of the gas tank filler neck where the gas cap was. So now all of a sudden we said, no muss to that. Now we got to have evaporative emission controls, which means we got to control all the hydrocarbons that are evaporating because of the heat, and we got to store them and then burn them later. So it was the year of the charcoal canisters. And that would be HC. Charcoal canister works like this. You know, charcoal is very absorbent. So now we're going to seal off the whole fuel system, and we are going to vent everything to the charcoal canister. That means anytime we get a pressurized fuel system, due to warming up of liquid fuel that turned into a vapor that increases the pressure, we're going to let that go to a charcoal canister. And the charcoal canister is going to absorb the fuel vapors. And then later, we're going to open up a valve between the charcoal canister and a vacuum connection to the intake manifold. And we're going to suck the vapors out of the charcoal canister and burn them as fuel. Well, you better have an oxygen sensor to do that, because if you don't, it's going to make the mixture run way rich, which is what it did for the longest. So we had big problems with this. We had big problems figuring out how to run the evaporative emission control system. Now, what you can't do is not when cold and not at idle. You can't run these systems when the engine's cold or the engine's at idle, because if you run it when the engine's cold, it'll probably kill the engine. And you can't run this system when the engine's at idle, because it'll probably kill the engine. So now we had to run ported vacuum out of our carburetors to make sure that we didn't run it at idle. And we had to have the thermal vacuum switch, so that this would only operate, the system, the evaporative emission controls would only operate when the engine was already warmed up. Okay, so now we've got this super complicated, well, it's super complicated. It doesn't seem super complicated now, but it sure did then. Because now you got all this valving to run the evaporative emission control system that you don't understand in the first place. And this is when we got 17 million vacuum lines. Because we were running everything on vacuum. We didn't have the sophistication to run this electronically. So now we got 17 million vacuum lines. The old Hondas had a box that had like 16 vacuum hoses going into it, any one of which would make your car run like crap. And there was no way of knowing which one was bad. Awesome. Freaking awesome. This was the 80s. This is why you don't see 80 cars anymore, because they sucked. 17 million vacuum lines. Now, all these vacuum lines, at least most of these vacuum lines have been replaced by electronics, which suits me and Rudy and Chuck just fine, Because not only is it done electronically, and we understand the electronic part, which is why I spent so much time on it in this class, but also because the computer is going to be monitoring the systems for us. See, the vacuum lines, the computer's got no way to monitor those. The electric circuits, yeah, it'll hook us up. It'll hook us up. So we used to have vacuum lines all over the place. Vacuum lines were like the spark plug wires of plumbing because they're soft rubber. And what are the enemies of rubber? Heat and oil. Well, guess what there is all over the engine compartment? Heat and oil. So the vacuum lines would go bad, and then all of a sudden it's like, okay, so now it runs weird, and I don't know why. Is it a spark plug? Is it a emission control thing? I mean, we didn't know. We didn't have smoke machines. We didn't have the diagnostic techniques that seem really primitive to us today. We didn't have them back then. The spraying of brake cleaner and stuff like that. We didn't understand that. Now it seems easy, but back then it wasn't. It was just terrifying. And most of the guys that graduated with me out of community college were like, "Oh, no, this is way too hard. No, I think I'm going to go do something else." That's why you don't see these cars on the road anymore, because they're too hard to fix. All right, well, it is currently 8:57. We're not going to get finished through this. So actually, we're making good progress, though. So any questions, comments, thoughts on that? Exciting news today about the school reopening.
I have a question about school reopening.
Yeah.
So when we go back into, or when we go into class, and so like, we're going to be working on vehicles, but we're going to be like, somebody's going to be doing hands-on while the rest of us are watching. Is that how that's going to go? I'm just curious.
Just a minute. Let me make sure that I read your question correctly.